Hi and hello. My name is Mimran Raja binti Amina Agus.
Hi everyone, my name is Nurul Atira binti Nurul Hisham.
Atira studying. How responsible?
Differentiation. Oh no. Distinction. Distinguish.
What a coincidence. Binra is spying on Atira.
Atira! What are you up to? Hey Mimra, I have a test coming up, but I'm a little bit confused about this. Do you know what is that? This. Distraction. Disruption. I don't know. Oh, it's differentiation. Yes, differentiation. Do you know what is that? What, differentiation? Yes. I don't know.
So, we'll talk about differentiation, which is our topic for today. So, we'll we get to know the definition of differentiation and the techniques we use in differentiation, and also we'll solve some exercise questions on differentiation and apply some of the techniques. So, what is differentiation? Well, differentiation is the process of finding the derivative of a function f(x), which represent the instantaneous rate of change of one variable with respect to another. In simple word, we can say differentiation is the method of finding the derivative of a function. Okay, now we look at the list of differentiation techniques, which is derivative of constant linear and power, derivative of sums and differences, product rules, derivative of trigonometric, exponential, and logarithmic function, chain rule, and the last one is quotient rule.
Next, let's move to question number 2.
Find the dy dx for the following function. So, for question A, we need to use product rule because it involves multiplication and exponentially plus power plus linear function. So, how to solve it? We need to divide them by u and v. So, for u, we know that that is exponent negative 2x, and for v we have 3x plus 1. So what we have to do is we have to find the u prime and also v prime. So how to find it? We need to differentiate u and v to get u prime and also v prime. So when we differentiate u, we get negative 2 exponent negative 2x, and v prime is 3. After that, we need to replace the value into the product rule method. So, as we know, product rule method is u prime multiple v plus v prime multiple u. So, just replace the value and solve it, and we get the final answer, which is negative 6x divided by exponent 2x plus 1 divided by exponent 2x.
Right now, let's move into question number 2b.
So, for question B, we need to change first the square root of x into x power of 1 over 2. Then, we can solve it by differentiate both sides, which is at first, we differentiate x power of 1 over 2. Then we get 1 over 2 x power of negative 1 over 2 plus cos 3x multiplied by 3 as the differentiation of since 3x, and then we get the answer is 1 over 2 x power of negative 1 over 2 plus 3 cos in bracket 3x. Then the final answer, we just wrote it as 1 over 2 divided by square root x plus 3 cos in bracket 3x.
Now, let us move to question 3. Given exponent power of 2y plus 2x equals to y to the power of 3 plus cos
in a bracket 4x. Find dy over dx using implicit differentiation. The first step we need to do is differentiate each one of them. D over dx in a bracket exponential to the power of 2y plus d over dx in the bracket 2x equals to d over dx in the bracket y to the power of 3 plus d over dx cos in the bracket 4x d over dx 4x. After we differentiate it, we'll get exponent power of 2y times 2 dy over dx plus 2 equals to 3y power of 2 dy over dx plus in the bracket negative sign in the bracket 4x times 4. Okay, to differentiate 2y, we'll be using implicit differentiation, which is d over dx in the bracket 2y equals to dy d over dy in a bracket 2y dy over dx. We differentiate it and we'll get 2 dy over dx. For y to the power of 3, d over dx in the bracket y to the power of 3 equals to d over dy in the bracket y to the power of 3. dy over dx, we differentiate it and we'll get 3y power of 2 dy over dx. So then we write it back down. The answer equals to 2 exponent to the power of 2y dy over dx plus 2 equals to 3y to the power of 2 dy over dx minus 4c in a bracket 4x. So we're going to place the number that have dy over dx at the same spot so we can factorize it. So it will be dy over dx in a bracket 2e to the power of 2y minus 3y to the power of 2 equals to negative 4 sin in a bracket 4x minus 2. So our final answer we'll get is dy over dx equals to negative 4 sin in a bracket 4x minus 2 divided by 2 exponent to the power of 2y minus 3y to the power of 2.
Okay,
So
now we move to the last question, question 4. It says use linear approximation to estimate the value of 1 over cube root 124.999 plus cube root 1 cube root of 124.999 to the power of 2. Okay, first thing we need to do to solve this question is we list down our x naught and delta x. For x, we'll get 124.999, and for x naught, we'll take 125 near to 124.99, and to get delta x is equal to x minus x naught, and we'll get negative 0.001. So our function is 1 over cube root of x plus cube root of x to the power of 2. Okay, then the next step is we need to differentiate our function. So it will be f prime x equals to d over dx in the bracket x to the power of negative 1 over 3 plus d over dx in the bracket x to the power of 1 over 3 times 2. We differentiate it and we'll get negative 1 over 3 times x to the power of negative 4 over 2 plus 2 over 3 times x to the power of 1 over 2. Okay, our next step is we'll need to use linear approximation formula, which is fx approximate to fx naught plus f prime x naught times delta x. We substitute our x and x naught and delta x into the formula. We'll get 1 over cube root of 124.999 plus cube root of 124.999 to the power of 2 approximate to 1 over cube root of 125 plus cube root of 125 to the power of 2, and plus negative 1 over 3 times 125 to the power of negative 4 over 2 plus 2 over 3 times 125 to the power of 1 over 2 and times it with negative 0.001. We'll get to 5.19986. We put it in correct three decimal places and we'll get 25.200 as our final answer.
To sum up, differentiation is a concept in calculus that allows us to measure the rate change in a function. The derivative in a function provides us with valuable information about its behavior at any point in its domain. By mastering differentiation, it will be easier to solve many problems in certain field of study or works.
Oh, now we know what is differentiation.
Differentiation question. I know this.